Welcome back everyone. Today we are going to discuss algorithms and its complexity. First we need to learn what is algorithm and afterwards we need to discuss about its complexity. So the thing is, what do you mean by algorithm? A program consists of data structures and algorithms. An algorithm is a set of steps required to solve a problem. An algorithm maps a set of input data to a set of output data through a sequence of operations, or we can say an algorithm is the set of instructions that defines not just what needs to be done but how to do it. So for this we can take an example of the cooking. Like consider to cook a new recipe, one reads the instructions and steps and execute them one by one in a given sequence. The result thus obtained is the new dish cooked perfectly. Similarly, algorithm helps to do a task in programming to get the expected output. The algorithm designed are language independent, that is, they are just plain instructions that can be implemented in any language, and yet the output will be the same as expected. So consider the example here. We can say that if you are having the input like 2 plus 2, so here set of rules means we need to write down the steps. Afterwards the desired output we required, that is 2 plus 2 is equal to 4. It means that for every algorithm we need to give the input, and afterwards after processing that input step by step we are getting the desired output. That is the thing we are going to be calling as a algorithm. As one would not follow any written instruction to cook the recipe but only the standard one. Similarly, not all written instructions for programming in an algorithm. In order for some instructions to be an algorithm, it must have the following characteristics. So the first thing is we can discuss, that is clear and unambiguous. Algorithm should be clear and unambiguous. Each of its steps should be clear in all aspects and must lead to only one meaning. Second one is we can consider about the well-defined inputs. If an algorithm says to take an input, it should be well-defined inputs. Third one we can say well-defined outputs. The algorithm must clearly define what output will be yielded and it should be well defined as well. Afterwards we need to think related to the finiteness. The algorithm must be finite, that is, it should not end up with infinite loops or similar. Next thing is we are having, that is a feasibility. The algorithm must be simple, generic and practical such that it can be executed upon will the available resources. It must not contain some future technology or anything. And the last thing is language independent. The algorithm design must be language independent, that is, it must be just a plain instructions that can be implemented in any language and yet the output will be same as expected. So while preparing the algorithm we need to consider these characteristics, and based on this we are going to be creating the algorithm. Now the important thing is how to design a algorithms. So when we are going to design an algorithm, we need to find out or we need to think about the following prerequisite. The first thing is the problem. So here we need to identify which problem we are going to solve by this algorithm. Afterwards we need to consider related to the constraints, like the constraint of the problem that must be considered while solving the problem. Next thing is we need to consider the input, like what are the inputs the algorithm it will take to solve a problem, and the thing is the output, like we need to find out the expected output when the problem is solved, and the finally is the solution, that is the solution of this problem in the given constraint. So problem, constraint, input, output as well as the solution we are going to be considering while we are going to designing the algorithm. So we'll take a one simple example, like we'll take an example of the addition of three numbers and print the sum. So the algorithm is written with the help of all above parameters such that it solves the problem. So the thing is, step 1, first of all we need to consider the prerequisites. So in the previous slide we have things like what do we mean by problem, what is the constraint, what is the input, what is the output, and what is the solution. So these are the things we are considering as the prerequisites are required to design an algorithm. So here we are trying to design our new algorithm for what? That is the addition of three numbers and print the sum. So the thing is, as discussed above, in order to write an algorithm, its prerequisites must be fulfilled. The first one is that is the problem. The problem that is to be solved by this algorithm, like what is the problem? Addition of three numbers and print their sum. Afterwards we need to go for the constraints. The constraints of the problem that must be considered while solving the problem. Like for this example, the numbers must contain only digits and no other characters, because we are doing the addition of digits, not the characters. The third thing is we need to consider about the input. The input to be taken to solve the problem. So here the three numbers we required as the input for the addition purpose. Next one is the output. The output to be expected when the problem is solved. So here in this example, the sum of the three numbers taken as the input and we are getting the output. And the last thing is we are considering about the solution, that is the solution to this problem in the given constraints. The solution consists of adding three numbers. It can be done with the help of plus operator or bitwise operator or any other method. So these are some solutions we are going to be used to solve that particular problem. This is the first step. Like whatever the prerequisites are there, we need to understand that prerequisites to prepare an algorithm. Like first we need to identify the problem, afterwards we need to check the constraints, proper input we required, proper output, and afterwards the solution, like after giving the input how to get that output. The second step we are having, that is designing an algorithm. Now previously we have checked what are the prerequisites we are having. Now the thing is stepwise we need to design an algorithm. Like consider the step 1 is starts, like every algorithm the step 1 it is going to be start and the last step we are going to be considering as a end. So afterwards we required the three integer numbers for the addition purpose. So here step 2 we need to declare the three integer variables, like consider the example number 1, number 2 and number 3. Afterwards we take the input, we need to take the input from the user. So we will take the input for the number 1, number 2 as well as the number 3 respectively. Afterwards we need to declare an integer variable, that is the name of sum. So here we are trying to store the sum of three numbers. Afterwards we are doing the sum, like add the three numbers and store the result in the variable sum, and at the end we need to print the value of variable sum. So like that we are going to be preparing the algorithm before doing any program. So this is the one simple example. Afterward the step 3, like testing the algorithm by implementing it. So in order to test the algorithm, we can write or we can use any C programming language or the C++ programming language or Java or anything. So by using these languages we can check the algorithm and we can try to find out the solutions. Like other examples we can consider, that is the swapping of two numbers or n number of things are there. So by using these prerequisites as well as the steps, we can design or we can prepare an algorithm. Now the thing is, the next point we need to discuss here, that is the different approaches for designing an algorithm. So here mainly we are going to be considering two approaches to design an algorithm, that is the top-down approach and the second one is the bottom-up approach. So in diagram we are considering this one, like left side we are considering that is a top-down approach, and this one we are going to be considering the bottom-up approach. So first we need to discuss about the top-down approach. The top-down approach basically divides a complex problem or algorithm into multiple smaller parts, or we are calling as modules. These modules are further decomposed until the resulting module is the fundamental program, essentially be understood and cannot be further decomposed. And that is the thing we are going to be calling as a top-down approach. It means that, like, consider this is the problem. So this problem we are going to be dividing into the sub problem. Again this sub problem we are going to be dividing like a sub problem, and like that we are going to be preparing the algorithm, and that approach we are calling as a top down approach. Now we are having the second approach, that is a bottom up approach. It is the reverse of the top down approach. Here the different parts of the program are first solved using the programming language, and these pieces of programs are combined into the complete program, and that is we are going to be calling as a bottom up approach. Now the next thing is, we have learned how to design an algorithm, what are the different approaches are there to design an algorithm. The thing is how to analyze an algorithm. For a standard algorithm to be good, it must be efficient. Hence, the efficiency of an algorithm must be checked and maintained. It can be in two stages. The first stage we are going to be calling as a priori analysis. The priori means we are calling as a before. Hence, priori analysis means checking the algorithms before its implementation. In this, the algorithm is checked when it is written in the form of theoretical steps. This efficiency of an algorithm is measured by assuming that all other factors, for example, processor speed, are constant, have no effect on the implementation. This is done usually by the algorithm designer. It is in this method that the algorithm complexity is determined, and that is the concept or considering as a priori analysis or before analysis. Second one, we are having the after analysis. Hence, after analysis means checking the algorithm after its implementation. In this, the algorithm is checked by implementing it in any programming language and executing it. This analysis helps to get the actual and real analysis report about correctness, space required, and time consumed, etc. So these are the two things or two ways we are going to be considering to analyze an algorithm. Now the thing is, we need to discuss about the complexity. Like we have learned the algorithm. What is the algorithm? Like algorithm we are calling as a steps. Like we are taking the input, we are writing the steps like the solution, afterwards we are getting the desired output. That is the algorithm we are writing, and the thing is, we need to check what is the algorithm complexity and how to find it. An algorithm is defined as complex based on the amount of space and time it consumes. Hence, the complexity of an algorithm refers to the measure of the time that it will need to execute and get the expected output, and the space it will need to store all the data, like input, temporary data, and output. Hence, these two factors defines the efficiency of an algorithm. So the two factors of a complexity are of an algorithm complexity are time factor, and second one is the space factor. The time factor is the time is measured by counting the number of key operations such as comparison in sorting algorithm. The second thing is the space factor. The space is measured by counting the maximum memory space required by the algorithm. So these are the two factors we are considering for the algorithm complexity, that is the time factor as well as the space factor. Therefore, the complexity of an algorithm can be divided into the two types. First one is the space complexity. Space complexity of an algorithm refers to the amount of memory that this algorithm requires to execute and get the result. This can be for inputs, temporary operations as well as or for the outputs. Now the thing is how to calculate the space complexity. The space complexity of an algorithm is calculated by determining following two components. First one is the fixed part, second one is the variable part. So the fixed part, this refers to the space that is definitely required by the algorithm. For example, input variables, output variables, or the program size, etc. Second thing is we are having variable part. This refers to the space that can be different based on the implementation of the algorithm. For example, temporary variables, dynamic memory allocation, recursion, stack space, etc. So by using this, we are going to be calculating the space complexity of an algorithm. The next one we are considering the time complexity. The time complexity of an algorithm refers to the amount of time that this algorithm requires to execute and get the result. This can be for normal operations, conditional if else statements or loop statement, etc. Now the thing is how to calculate the time complexity. The time complexity of an algorithm is also calculated by determining following two components. The first one is constant time part. That is, any instruction that is executed just once comes in this part. For example, like input, output, or if else or switch, etc. And second thing is we are considering variable time part. So here any instructions that is executed more than once, say n number of times, comes in this part. For example, we can say as a loops or the recursion, etc. And by using constant time part and variable time part, we are going to be calculating the time complexity. It means that, so the complexity means how much space it will require and how much time it will require to execute a algorithm. So basically the time factor and space factor, it is going to be considered over here. And the thing is space complexity, how much space it is going to be considered to execute an algorithm, and time complexity means how much time it will take to execute an algorithm. Now the thing is how to do the analysis of an algorithm. The thing is we can have the three cases to analyze an algorithm. The first one we are calling as a worst case analysis, second one we are calling as the average case analysis, and the last one we are considering as a best case analysis. So we will discuss the first one, that is a worst case analysis, that is usually done. In this worst case analysis, we calculate upper bound on running time of an algorithm. We must know the case that causes minimum number of operations to be executed. That is we are going to be calling as a worst case. Second one we are calling or considering the average case analysis, that is sometimes done. So in average case analysis, we take all possible inputs and calculate computing time for all of the inputs. Sum of all the calculated values and divide the sum by total number of inputs. So in that case we are getting the average case. And the last one we are considering, that is the best case analysis. So in best case analysis, we calculate lower bound on the running type of an algorithm. We must know the case that causes minimum number of operations to be executed. So it means that to analyze an algorithm, we are considering the worst case, we are considering the average case, or we are going to be considering the best case. So here we can take an example for the searching a key element from the given list. So like consider we are having the numbers like 1, afterwards 2, afterwards 3, afterwards 4, and last one is we are having, that is the 5. Now the thing is, we need to design an algorithm to search a key element. Like we are going to be searching the key element, that is we are going to be calling as a k. So when we are going to be considering the key element, so basically we will check for the worst case. Now consider the key element we need to search, that is the 5. So first k, it is going to be compared with the 1. So both are equal, not equal, then go to the next one. Again 2, it is going to be compared with the k. 2 and k, the value of k is 5, so we need to go to the next one. 3, it is going to be compared with the 5, not equal, go to the next one. 4, it is going to be compared with the 5, not equal, go to the next one. At the end 5 equal to 5, so here we are getting the number, that is we are at the end we are getting that particular key element searched in the given list. That is the thing we are considering as a worst case. Second one, we are having the average case, like either we'll get the number at the first position or the second position or third, fourth or fifth. We don't know where exactly it will get, so that is the thing we are calling as a average case. And the last one, we are having the best case. Like consider if we are having the k is equal to 1, so the when the key element it is going to be compared with the first element, so we will get like 1 is equal to 1. So in the first case only we are getting the result, and that is the thing we are going to be calling as a best case. So like that, for every algorithm we can consider or we can analyze the algorithm by using the worst case, average case as well as the best case. So today we have learned what do you mean by algorithm, how to design an algorithm, afterwards what do you mean by complexity of an algorithm, and how to analyze the algorithm. Thank you.